We construct residential neighborhoods faster today than at any point in history. A crew can frame a standard house in a matter of weeks. But speed has a direct cost when measured against the relentless force of gravity and weather. Nature eventually stress tests every piece of lumber and every nail we leave exposed to the sky. To see what durability looks like, walk through downtown historic districts. Buildings like the State Theater were constructed over a century ago. They rely on heavy brick and thick mortar, materials chosen specifically to outlast the people who laid them. Modern residential construction operates on a completely different timeline. Most contractors optimize their workflows to meet the bare minimum local building codes, keeping costs low and turnover high. As a result, the average new home is engineered on a 10 to 25-year horizon. The minimum code is treated as the ceiling for quality, rather than the absolute floor. The physical consequences of optimizing for speed appear within a single decade. Wood framing begins to warp, cheap window seals break, exterior siding starts to rot, and water breaches the basement concrete. Building a multi-generational legacy home is a strict engineering challenge. It requires looking past the surface-level aesthetics to deliberately outthink the elements that want to tear the structure down. The first step in that engineering challenge is geology. In the Appalachian region, builders deal with expansive clay soils that swell when wet and shrink when dry. The natural rolling slopes dictate exactly where water will pool, and the underlying limestone, known as karst topography, can hide unseen sinkholes. This diagram illustrates hydrostatic pressure. This is the constant crushing weight of groundwater pushing horizontally against the concrete foundation walls. If water sits against the buried side, the mass forces moisture through the pores. The minimum standard, damp-proofing, is just a thin liquid that eventually decays, letting water breach the interior. To stay dry for a century, you wrap the concrete in a rubber membrane and a dimpled drainage board. This breaks the pressure, channeling water into a drain pipe before it ever touches the wall. Below the walls, the footings hold hundreds of thousands of pounds. We pour these wider and deeper than code, using 4,000 psi concrete. We fortify that concrete with heavy bridge-grade steel rebar to handle the stretching and pulling forces that would normally crack an unreinforced slab. If the soil shifts or water defeats the foundation, every structural layer on top is doomed. The anchor has to be perfect. Once the foundation is set, the frame goes up. Standard green lumber from a big box store holds a massive amount of water. As that wood is sealed inside your walls and begins to dry out, it shrinks, twists, and splinters, pulling the drywall with it. We eliminate this movement entirely by using engineered lumber, specifically laminated veneer lumber, or LVL. LVL beams are made by gluing thin layers together to create a product stronger and straighter than a log. They arrive dry and never shrink. Most builders use OSB, cheap, compressed wood chips that absorb water and swell like a sponge. By upgrading to CDX plywood, the exterior skin remains rigid and intact. This creates an incredibly tight skeleton. It removes the internal tension that causes drywall to crack and prevents floorboards from squeaking. The skeleton is the rigid inner truth of the home. When the framing is stable, the geometry never betrays the finishings attached to it. The exterior envelope takes the full daily impact of UV rays, heavy snow, and driving rain. Cheap vinyl siding expands aggressively in the sun, while standard wood siding rots completely through within 20 years. The rain screen is a deliberate half-inch gap between the siding and the house wrap. Air flows upward through this gap, drying any moisture that penetrates the outer layer. For the siding itself, natural Tennessee stone and heavy brick masonry offer permanent resistance to the climate. Fiberglass windows expand at the same rate as the glass panes, ensuring the factory seals stay airtight for decades. At the very top, standard asphalt shingles are just paper and oil. The sun bakes the oil out of them until they crack. A heavy, standing seam metal roof, or natural stone slate, completely repels water and easily survives a century of extreme weather. Instead of aluminum, which develops pinholes over time, we seal vulnerable intersections with solid copper. It is impervious to rust. Heavy masonry, a rain screen, and a copper-sealed roof turn a temporary shelter into an impenetrable, self-drying fortress. A house that survives a century also has to be heavily lived in. The plumbing and electrical lines act as the veins and nerves of the structure. If they are incredibly difficult to repair, future generations will be forced to tear the walls apart to maintain them. This schematic contrasts a traditional plumbing layout with a manifold system. Using PEX-A, a flexible plastic piping that is resistant to breaking, the manifold layout replaces hidden, vulnerable joints inside the walls. Every single pipe runs continuously back to one centralized hub, allowing you to isolate a single leak without shutting down the entire property. For the electrical grid, we install oversized conduits. These are hollow pipes running behind the drywall that house the wiring. 50 years from now, when technology requires completely different cables, a homeowner can easily pull the old wires out and slide the new ones through the conduit without breaking a single piece of sheetrock. Committing to these hidden structural upgrades is a total rejection of the disposable culture that dominates modern development. It requires turning away from the quick, the cheap, and the easy. It demands significant upfront capital and, more importantly, uncompromising precision in the dark places of the home that no guest will ever actually see. Anchoring a home with absolute foundational integrity creates a permanent, multi-generational legacy. The structure will stand upright long after the hands that built it are gone.